In today's video, we're going to understand and write relations. And you have heard of the word relation, relationship, and related. And it usually talks about some sort of connection. It's the same way in mathematics. In math, a relation is a rule that describes how two sets of items correspond to each other or how they're connected. This correspondence can always be written as a set of ordered pairs, like how you've been doing as you've been graphing in XY pairs. In addition to writing a relation as a set of ordered pairs, we can also write them as a table, a mapping, and if they are numbers, a graph. Let's go through an example. Generally with our relationship, our set of ordered pairs can be read as inputs and outputs. I like to think of it that way so that I can keep track of things. And I often think of it as like a machine or a computer. You're putting something in and it gives you something out. So in the map, we're going to have inputs on the left and then outputs on the right. And we're talking about whenever we have something where it's like students and the colors they're wearing, the first thing is going to be the thing we put in, and then the second thing is going to be the thing we get out. So we're going to put students on the left of this map and then what color they're wearing on the right. So I'm going to say that there's Beth, she's a student, and she's wearing blue and white. Now to show that she's wearing those colors, you're going to draw an arrow from Beth to each of the colors she's wearing. Pretty easy. If there's a color she's not wearing, like black, then there's no arrow going from Beth to that color. However, we're going to say John, he is wearing black, and he's also wearing white. And then Thomas, he is wearing very patriotic colors today. He's going to wear red and white and blue. So this mapping is pretty easy to understand, but can get kind of hard to read when you have a lot of arrows. But basically it means that you look on the left, that's the person, on the right is the colors they're wearing. Or for each input, the outputs that will come out when you put in that input are connected by an arrow. Another way that we can represent this is through a table, which is a little bit easier to read. We're going to put the input, which you are used to having it be XY. The input is always our X. So our input is the student and our output is the color. So I'm going to put Beth. Now you may be tempted to put it like this, blue and white. The problem is that it gets really hard to compare who all is wearing what color if you have like all the colors they're wearing. If one person's wearing tie-dye, then it starts getting really long and you don't know if they're actually wearing red or not. So we're going to make it so that each arrow that you see on the graph is just one entry in the table. So we have Beth is wearing blue. That's one arrow. Now Beth is wearing white. So all our Beths are out of the way. We got rid of those two arrows. Now let's do the John entries. He's wearing two colors, so I'm going to put him twice. And he's wearing white and black. Oh, sorry. I added an extra E onto white. There we go. And then Thomas, he's wearing three colors, so we'll put him 3 times. And then it was red and white and blue. Now, just like when we do with graphing, we can write these as a set of ordered pairs, and the ordered pairs will come right off the table. You can literally just lift it off. So this is going to be an ordered pair. Now, when we write a set, we do like these little squiggly brackets, so that indicates a set. That means that all of these things are connected somehow. Okay, so I'm going to put Beth is wearing blue as our first item, then put a comma. Beth is wearing white. So this indicates that Beth is connected to both blue and white. John is wearing white. And this can take a while, so let's just go ahead and write these down. Now, usually this will end up showing as a list that shows up horizontally. I'm just running out of space. Thomas Red, Thomas White. Don't forget your parentheses. And Thomas Blue. Frequently when we're dealing with things in, with relations in mathematics, we usually just simplify everything to a number. And most of the times the relations will be sets of x, y pairs. So let's do another example where we write a relation in multiple different forms. In this one, we have a set of ordered pairs already given to us. Remember that all of these ordered pairs are written x, y, where x is the input and y is the output. So the input is always the first number and the output is always the second number. Now, to write a map, you don't ever repeat any numbers on the side. So like if you see 2 as the input twice, you're only going to write it in the input box once. So that's a thing that I see a lot of people get wrong. So let's go ahead and we're going to write these down. I have my input on this one as -4, and then my output is 3. So I'm just going to draw that having an arrow there. Then I have 0 and I have 4. Draw an arrow. Then I have 1 and -1. Draw an arrow. Then I have 2 and 1. Draw an arrow. And then I have 3, and 3 was already written, so I'm going to draw an arrow to that guy. And then I have one more. 1 goes to 2. I already have an input of 1. Do you see it right there? So if 1 goes to 2, there isn't a 2 on this other side, so I'm going to write it in and draw it over there. That was a little quick, but you can do it just as quickly. So make sure that you don't have like, we could have had 2 1s, but instead we just showed that 1 goes to both 2 and -1. And we could have had, what else could we have had? We could have had 2 3s in the output range, but we just showed that both -4 and 3 go to 3. That way we can analyze a little bit better how this works. Now in your table, you're going to write it as x, y, and just like we did up above, you are going to just write everything as is. So this one's pretty easy. We're going to write -4, 3, 0, 4, 1, -1, 2, 1, 3, 3, 1, and 2. Be careful to write these in the order they appear and not flop them. Now, all of these ordered pairs are things that we can graph. Hopefully you remember how to graph. If not, here's a quick review. Remember that the x-axis is going to be your inputs or your first number. Your y-axis is going to be your outputs or your second number. Each ordered pair is a distinct point on the graph, unless of course it has the same numbers. So we have -4, +3. -4, +3 is there. And then 0, 4, 0, so it doesn't go left or right at all, and then 4 is 4 up. And then 1, -1, 2, 1, 3, 3, and 1, 2. Okay, so we were given a set of ordered pairs and we wrote this relation in 3 other ways. I'm going to show you real quick how to just make your table turn into a bunch of ordered pairs. Hopefully it's really easy. You can just read them as parentheses, literally like that. So we're going to take this and write -1, -3, then comma, then 2, -1, then comma, 3, 1, comma, 3, 0, comma, and 4, 1, comma. And then to indicate that it's a set, you put your little squiggly brackets saying all these points are together. We're talking about all of them at the same time. And hopefully, now that we've done our set of ordered pairs, try doing a map just like we did in our example 2, and a graph like we did in our example 2.